Hello viewers, in today's session we are going to discuss another important and conceptual problem from three-dimensional geometry related to intercept form of equation of a plane. And here we are going to solve this problem where we have to find the equation of the plane passing through the points whose coordinates are 3 comma 2 comma 0 and 3 comma 6 comma 4. And here an additional condition is also given, that is if the sum of the intercepts made by the plane on the three axis is equal to 1, right? So here we are going to make use of the concept of intercept form of the equation of a plane to solve this problem, right? So here we'll make use of this equation, that is x over a plus y over b plus z over c is equal to 1. So this equation is known as the intercept form of the equation of a plane where the plane makes the intercept A on the x-axis, B on the y-axis, and C on the z-axis. So let us quickly revisit this equation. Suppose here we have the axis, and here we have x-axis, here we have y-axis, and here we have the z-axis, and O is the origin. And suppose we have a plane like this which cuts the three axes at these points, that is, this is the point A, this is the point B, and this is the point C, right? And the intercept made by this plane on the three axes are given by A, B, and C. That is, the coordinates of this point A are given by A, 0, 0. The coordinates of this point B are given by 0, B, and 0, and the coordinates of the point C are given by 0, 0, and C. So A is known as the intercept made by the plane on x-axis, B is the intercept made by the plane on y-axis, and C is known as the intercept made by the plane on the z-axis. So whenever we are given the intercept, that is the length of the intercept made by any plane on the three axes, then the equation of the plane can be represented by this equation. So this equation is known as the intercept form of the equation of a plane, right? So here we are going to make use of this equation to solve this problem. So here we have to find the equation of the plane which passes through these 2 points. So here we have the first point 3, 2, 0, and the second point 3, 6, and 4. So we'll assume that let the equation of the plane be of this form: x over a plus y over b plus z over c is equal to 1, right? So here an additional condition is also given, that the sum of the intercepts made by the plane on the three axes is equal to 1, and the intercepts are A, B, and C. So we are given that A plus B plus C is equal to 1. So let us take this equation as equation 1 and this equation as equation 2. So this is the equation of the plane in the intercept form, and here we are given that the sum of the intercepts made by the plane on the three axes is equal to 1, right? So now we have here three conditions, that is this plane passes through these 2 points and the sum of the intercepts is equal to 1, and here we have three unknown quantities, that is A, B, and C, and we can find out A, B, C by using these three conditions. That is, the plane passes through these 2 points and the sum of the intercepts is equal to 1. So now let us first make use of these two conditions. Now this plane passes through this point. That is, this point satisfies the equation of the plane. So here we can now take x is equal to 3, y is equal to 2, and z is equal to 0. So taking x is equal to 3, y is equal to 2, and z is equal to 0 in this equation, we have 3 over a plus 2 over b plus 0 over c is equal to 1. Now 0 over c is equal to 0, so we have simply 3 over a plus 2 over b is equal to 1. So we can take this equation as equation 3. Now this plane also passes through this point 3, 6 and 4. So taking now x is equal to 3, y is equal to 6 and z is equal to 4 in this equation, because this point also satisfies the equation of this plane. That is, these 2 points lie on this plane. So we have now 3 over a, then we have 6 over b, and then we have 4 over c is equal to 1. So let us take this equation as equation number 4, right? So now what we will do, will solve these three equations, that is equation 2, 3 and 4, to get the values of a, b and c. And once we get the values of a, b, c, we can substitute them in this equation 1 to get the required equation of the plane. So now let us first solve these two equations. So here what we can do, we can subtract 4 from 3. So we can now write 3 minus 4. So here we have in the left hand side we have 3 over a plus 2 over b, and then we have minus, and we have here 3 over a plus 6 over b plus 4 over c, and in the right hand side we have 1 and 1. So we have 1 minus 1, that is equal to 0, right? So here we have 3 over a plus 2 over b, then here we have minus 3 over a minus 6 over b minus 4 over c is equal to 0. So now these two terms get cancelled, and here we have 2 over b minus 6 over b. So these two terms are like terms, so we have 2 minus 6 over b, then we have minus 4 over c is equal to 0. So we have now minus 4 over b minus 4 over c is equal to 0. So now taking this term to this side, we have minus 4 over b is equal to 4 over c, and taking cross multiplication here, minus 4c is equal to 4b, and here 4 and 4 get cancelled. We have minus c is equal to b, or we can take c is equal to minus b, right? So solving these two equations, we have obtained this condition, c is equal to minus b. So let us now substitute this value in equation 2. So we have a plus b, and for c we have minus b, and this is equal to 1. And here we have a plus b, and here we have minus b, and b and minus b get cancelled, so we have simply a is equal to 1, right? So now we have a is equal to 1. So let us substitute this value of a in equation 3. So taking a is equal to 1 in equation 3, we have now 3 over 1 plus 2 over b is equal to 1. So 3 over 1 is 3, and here we have 2 over b is equal to 1. So 2 over b is equal to 1 minus 3, taking 3 to this side, that is equal to minus 2, right? So we have 2 over b is equal to minus 2. 2 is equal to minus 2b, multiplying minus 2 with b, and here b is now equal to 2 over minus 2, that is equal to minus 1. So the value of b is equal to minus 1. So now if we take b is equal to minus 1 in this equation, then the value of c is equal to minus and minus 1, that is plus 1. So the value of c is equal to 1, right? So now we have obtained the values of a, b and c, and let us substitute the values of a, b, c in equation 1 to get the equation of the plane passing through these 2 points, and the sum of the intercepts is equal to 1. So we have x over 1 plus y over minus 1 plus z over 1 is equal to 1. So we can now write this equation as x minus y. We can take this negative sign over here, and then we have plus z and is equal to 1. So this is the required equation of the plane.